So this question day is fx, and then at the same time they tell you fx and other point of view is this bracket times this bracket, and then they ask us to find out a, b, and c. So do not like the typical question. They don't give us when fx divided by something, what is the remainder. So at this moment we are not going to use the remainder theorem. We're just going to look at why they give us 2x in two different aspects. So at one point of view, fx is equal to x power 3 plus kx squared minus 3x minus 3. At another side, fx is equal to x minus 1 times ax squared plus bx plus c. A very important thing is these two are definitely the same thing, okay? But you can't compare directly the relation between a and 2 or a and negative 3 is because they are not in the same format. So you're going to expand the bracket and then compare term by term because they're just simply exactly the same. One example of identity is 2x plus 3. Then it's always equal to something. What's that? Only one possibility is 2x plus 3, which means that every term are the same. So that's why we need to ensure they are in the same format first, then we can use this logic. So I consider that I remove the first bracket. There are two items, x something and negative 1 something. So that something is ax squared plus bx plus c. But I seldom ask my student to write in this way. I ask them to write in two columns, as two rows. So negative 1 here, and then something. So ax squared plus bx plus c. So the first row, every term we have to times x. So we have ax power 3, bx power 2, cx. And then the second row, everything we have to times negative 1. Ax squared times negative 1, negative ax squared. But I won't write it below because I want to use the same column to identify the like terms. So I write down negative 1 ax squared, negative bx, negative c. Or you may just write negative ax squared. So this is ax power 3. This is plus b minus a times x squared. How many x we have? C minus b times of x, and we have negative c. Now we successfully separate them to 4 terms one by one, which is the same format as this one. So I just simply copy down once again this one, and fx is equal to 2x power 3 plus kx squared minus 3x minus 3. So just now, just like what I told you, every term must be the same. That means these two basically must be the same thing. Therefore, we know a is equal to 2. Second finding, we know that this is also exactly the same as each other. So we know b minus a is equal to k. Repeat the same thing term by term, so we also know that c minus b, that means negative 3. The last group, we know that negative c is equal to negative 3 here. I just list out all the conclusion that we can make. Sometimes some of the conclusion may not be useful. This one is useful. They give us something like a. But this one is not really useful because there are b and k, two unknowns here. And k is not asking. So we don't care about what is k in it. And then, so we find that this one is useful, and the next one is this one because they give us c very easily. C is equal to positive 3. Before that, we don't know c and b together, but now we already know what is c. Therefore, this is 3 minus b equal to negative 3. Negative b is equal to negative 6. B is equal to 6. To conclude, A is equal to 2, B is equal to 6, and C is equal to 3. Basically, this technique is what we learned in Form 2, and this technique to compare term by term is called comparing coefficient. Because we are comparing the number in front of the variable of certain term only, so we are comparing coefficient A and coefficient 2 here. This is called compare coefficient. And then continue to part B. Again, we always stick to the question. They ask us to solve the equation fx equal to 0, and then later on we are going to check the result are all real numbers or some of the solution is not real number. That's what we want to know. So we start from fx equal to 0, solving this. Solve fx equal to 0, and then we have two choices here. Fx in this format or fx in this format. Which one is more favorable to solve the equation? Of course, the factorized format is much better for us to solve the cubic polynomials. And one of the very important hints is A, B, C is asked, but we don't care about K. So this is not our good choice. We will choose this one. So x minus 1, ax squared plus bx plus c. This format is easy for us to further solve the equation. And then a is known, which is 2, x squared plus 6x, and then plus 3 equal to 0. And x minus 1 equals 0, the first factor equals 0. Or if not, then the second factor should equal to 0. This is the zero product rules. X is equal to 1. And this one from a cubic polynomial is downgraded. We just focus on the quadratic. So we use the quadratic method that we learned. You may use calculator formula 1, or you may solve it by factorization if you can. Or if you can't, you may use quadratic formula. But if you look at the question, they ask you, are they all real numbers? That means what we concern is whether they're real or not. To check whether the quadratic equation will give us real solution or non-real solution, we may just consider parts of the quadratic formula. Consider delta. Delta is equal to b squared minus 4ac. That means what inside the square root? Something squared minus 4 something. B is 6, A is 2, C is 3. So 36 minus 24, we got 12. It is larger than 0. That means in our quadratic formula, there will be square root 12, which is real. So 2 real roots, or 2 distinct real roots, more precise. So the first solution, it is real solution. And this part will give us 2 more real roots. So all the roots are real. Then we just simply agree the statement. Since all 3 roots are real.